Okay guys, in this video lesson we're going to kind of take the next step in terms of working with moles. If you recall, the last thing we did is we worked with moles and mass, and we found out this ability to convert from moles into mass and mass into moles. Okay, so the next step is once we have that ability to go in and out of mass and moles, is we need to somehow apply that to a balanced chemical equation. Okay, so to do that, we need to be able to look at a balanced chemical equation for the first time in kind of viewpoint from moles. Okay, so if we take a look at something simple like this, we have propane here, C3H8, reacting with oxygen to make carbon dioxide and water, so kind of a typical combustion reaction. And if we look, we have a 1 to 5 to 3 to 4 ratio. Now, up until this point, we just kind of assumed that those were atoms or molecules or kind of an amount. And they are. They are just an amount to them. So for every 5 O2s, we need 3 CO2s. For every 4 waters, we need 1 propane, and so forth. What we haven't talked about up until now is the fact that we can actually use this as a mole ratio. Okay, so you can apply the concept of amounts by using moles here. And here's where the power of the mole really starts to come out for us. Because instead of having to count Avogadro's numbers worth of oxygen to get to a mass, we can just say, well, if there's a 5 here, that means there's 5 moles of oxygen needed for every 3 moles of carbon dioxide produced and for every 4 moles of water produced. Okay, so really this concept here is the ability for us to take one substance and then relate it or convert it through dimensional analysis to another substance. So if we know how much of this we start with, we can know how much of this we need, how much of this we'll make, how much of this we're going to make. Okay, so let's take this idea and go down and do some practice stuff with it. Okay, so if I have 4 moles of propane, how many moles of carbon dioxide can I make? Okay, so if I have 4 moles of this, how many moles of carbon dioxide do I make from that? Okay, now you might be able to answer that off the top of your head. Say, well, it's a 1 to 3 ratio. If this becomes a 4, that's 3 times that, it's 12. Okay, so we get 12. Awesome. Now, if we want to look at that through the concept of dimensional analysis to give an idea of what we're talking about here, if we have 4 moles of propane, the equality there is that we know that we have 1 mole of propane for every 3 moles of our carbon dioxide. Okay, so this step right here comes from the balanced equation. Okay, and again, so we take our 4 moles of propane cancels, and we convert to moles of carbon dioxide instead. And obviously 4 times 3 is 12 moles of CO2. Okay. Now you might be thinking, wow, that's a lot of work for just taking something times 3. I can do that. That's fine, which is good. I agree with you. You probably can. What gets tricky is what happens when things don't line up as easy with the math. Okay. So the next one isn't hard yet, but isn't quite as easy. If you want to make 18 moles of water, how many moles of oxygen will be used? Okay. So we want to make 18 moles of water. And we want to figure out how many moles of oxygen is going to be used. So we know that moles of water we want to cancel. And we want to figure out moles of oxygen. Okay, so we go back to our balanced chemical equation. So for water, it's a 4. And for oxygen, it's a 5. So what is 18 times 5 divided by 4? Okay, so if you can't do that in your head, you take 18 times 5 divided by 4. Punching my calculator down here. Okay, and if we do that, we get 22.5. Okay, so again, you might be able to do that in your head. And if you can, that's great. But this is just, again, one step in a bigger process that we're building towards. Okay, so 18 times 5 divided by 4, and we end up getting 22.5 moles of oxygen is what we need for that. Okay, so we're able to take one substance, because of an equality within a balanced chemical equation, convert to another substance. So the key for this reaction is we're converting from water to oxygen. And that's why you notice in my labels, I'm actually putting the compound inside the dimensional analysis. Because moles is the same here, it's moles and moles. What's different is the substance in this step. Okay? All right, guys, it's a little short video lesson, but that's what we want to talk about here. In our next lesson, we will actually go down the lines and we will start going into this idea of stoichiometry. So putting together things that we've already talked about into multi-step problems coming up next. All right, thank you.